Welcome to Edibon. For over 30 years, we have provided premier technical teaching equipment across the globe. Our product range covers most technical areas which include engineering, physics, electronics, communication, and renewable energy. Every Edibon product is designed, manufactured, and quality controlled at our headquarters in Madrid, Spain under several quality standards.
So you may be thinking, what is an SCADA? A SCADA is an acronym for System or Supervision, Control, Acquisition, Data. So basically, a SCADA is a data acquisition and control system. It is Edibon's original computer-controlled system. Many of Edibon's computer-controlled units have a SCADA with PID control. This is a valuable addition to the SCADA system. The PID, or Proportional Integral Derivative Control, is the most common control used in many unitary processes and industrial applications. With SCADA, each variable in PID can be individually manipulated. We can analyze any process in any unit by changing the proportional gain and/or integral time and/or derivative time. There are some other parameters that affect the result that can be adjusted one by one, such as gain, offset, and volts. The purpose of the computer-controlled system is to control any unit operation or unitary process. The industry uses all of these levels, but Edibon is the leader of this technology in the teaching market. This group allows many divisions as follows. These open control facilities are so important for teachers as they can explain all concepts involved in the PID control very quickly in a clear way for the students to understand. The PID concept is not clear for most professional engineers working today in the industry, but by using the Edibon computer control SCADA with PID control, all the students can get a clear concept, quick understanding, and it is easy for the teachers to explain these important concepts. Multi-control is similar to open control, but with many parameters under open control at the same time, meaning the results of multiple sensors are visible at the same time, as well as their graphed curves. Any pump, valve, etc. can also be changed at any time. We say that we use real-time control because all of the information arriving to the computer from the unit throughout the interface are all electronic signals that move very fast in nanoseconds. Multi-student post allows multiple students to work with a unit at one time. The system allows connection to an electronic whiteboard or projector visible to the entire class. The instructor can explain to the entire class at once, as well as compare the results of the students. Most importantly, you have computer control over the unit by using the electronic whiteboard. LabVIEW is a software structure designed by National Instruments that allows any user to design their own software for their own applications. The LabVIEW software is considered a very standard software and is well known in probably all departments in higher education institutions in the world. Once you understand how to use the software with one unit, the other units will be easy to operate because they are all similar. National Instruments software is used globally in industrial applications or processes. Therefore, Edibon software provides valuable experience to the student. Another practice possibility of the system is to use the programmable logic controller. The PLC can be used with or without the personal computer to implement each process control. It provides hands-on with the unit process with programming exercises, and it is compatible with requirements of industrial processes. The SCADA-Net teaching system allows 30 students to work at the same time and with multiple units simultaneously. Please follow the link below for more details on this expansion. software for the UCP unit controlled through the electronic whiteboard. You can see all of the features that make up Edibon's SCADA system. Open control with the ability to change multiple parameters during the experiment, and multi-control with multiple sensors and parameters. To demonstrate real-time control, I will open the valve on the software and the unit immediately responds. The data acquisition system in our computerized units monitors and displays the data, records and stores the data, and plots or graphs the data. The data acquisition board has no control over the unit. It only records the data samples in the computer rather than the old-fashioned way of the student manually logging all of the data points. Edibon uses a data acquisition board that records 250,000 samples per second and 2.5 million for telecommunications, which is required for analyzing the curves and results. Pure simulation software allows you to simulate on the computer the real process, but all the data handled is theoretical. Edibon only uses this in complex, high-tech electronics. Teachers CAI allows the teachers to organize and control the students. They can view the students' progress and detect difficulties. They can assess them with exams, etc. The student CAI provides a detailed explanation of the theory. It also has practice exercises in which the computer guides the student. These two computer-aided instruction software systems are available for basic electronics, digital electronics, basic electrical concepts, electronics applications, and controls. View the catalog for exact units. The CAL calculation software makes calculations and plots the curves of the data by using the appropriate formulas. This software is available for basic fluid mechanics, basic electronics, telecommunication, electricity, and mechanics. The Edibon teaching units are the only ones in the market providing total safety. So what does this mean? Suppose the mechanical or electrical device fails for any reason, meaning the pressure switch is broken or blocked out or cut out for bad student intention. If this is the case, the electronic device works and cuts off. If pressure increases to a dangerous level. How does it work? The pressure sensor is regulated for working in a particular range, sending proper millivolts or milliamps to the electronic interface. So if this amount exceeds the electronic system in the interface, it cuts off. But suppose that the mechanical safety device fails and the electronic safety device fails, or the student cuts it out. In this case, the software device operates as the software package has designed it for working only inside a particular pressure range. We explained the situation with pressure, but this philosophy can be applied to any sensor used in any Edibon computer-controlled unit. When a teacher buys Edibon computer-controlled unit, he must know that everyone working with the equipment is totally protected. SCADA drastically increases the efficiency of the teachers and the student. It reduces wasted class time and laboratory cost. It provides students with clear concepts of industrial applications, and it has future expansions with more Edibon units. Here are some examples of units with computer control. The UCP unit is one of the best units to visualize the importance of computer control and how it is relevant in all industrial applications for the future. Edibon has technical teaching units available with their unique SCADA computer-controlled system throughout the entire catalog. Thank you for viewing this video. I hope that you now have a clear understanding of computer control and Edibon's SCADA system. I encourage you to watch the Edibon SCADA-Net video to see the expansion possibilities of the SCADA system. You may also find the video on the UCP unit interesting as it provides more information and a demo of the unit under computer control and utilizing SCADA.